Okay, so for the past few days, we've been practicing solving systems by graphing, and that works really well whenever you're thinking about the slope and y-intercept, and the y-intercept is a beautiful, nice integer. But there are times where when you solve for y equals mx plus b, that the y-intercept isn't a pretty y-intercept. So there are times where we can use different methods. The second method that we could use is solving systems by substitution. Honestly, it comes down to the kinds of equations that you're dealing with. If you notice that one of your equations is solve for y or solve for x in a lot of cases, then this is where substitution comes in handy. It's less work than the traditional way for solving for y equals mx plus b. So let me just show you how it works. So number one, when one of the equations is solved for one of the variables, it doesn't matter if it's y or for x, we are going to substitute. So what I mean by that, since y equals 6x, we're going to substitute 6x in for the y of the second equation. So if I rewrite it, it's 2x plus 3 times 6x equals negative 20. And then we solve like we're solving regular equations, where I distribute, simplify, and solve for x. So 2x plus 3 times 6x is 18x equals negative 20. Then we're going to combine like terms, so 2x plus 18x is 20x equals negative 20. Then we're going to divide by 20. So x equals negative 20 divided by 20 is negative 1. Now, that has helped us solve for x. So to find the y of the solution, we're going to take what we get for x and substitute it back into one of the equations. It doesn't matter which equation, you just kind of want to be smart about, well, do I want to do more work or less work? So if I substitute negative 1 in for the x of the first original equation, it's pretty simple because all you do is 6 times negative 1 is negative 6. So y equals negative 6. So my solution, or my ordered pair, like if we were to graph it, would be negative 1, negative 6. And there's my answer. So let's try it again. If you look at number 2, one of the equations is solved for one of the variables. So in this case, they solved for y. So y equals x plus 9. So if I take x plus 9, I'm going to substitute it in for the y of the second equation because that's what y equals. So we're going to rewrite it. 3x plus 8 parentheses x plus 9 equals negative 5. And then we're going to distribute and solve. So I have 3x, 8 times x is 8x, 8 times 9 is plus 72 equals negative 5. And then I combine like terms, 3x plus 8x is 11x, plus 72 equals negative 5. Then we're going to subtract 72. So 11x equals negative 5 minus 72 is negative 77. Then I'm going to divide by 11. So my x value equals negative 7. So then we're going to take that x value and substitute it back into one of the original equations. Again, I can choose where I want to substitute the x in. It just comes down to which one's the simplest. And truth be told, it's the original here on the first. So if I substitute negative 7 in for x, negative 7 plus 9 is positive 2. So y equals positive 2. So my solution is negative 7, comma 2, my x and my y coordinate. If I look at number 3, another time, this time my equation is equal to x. So what that means is this time I'm going to take 4y plus 7 and substitute that in for x and rewrite that second equation. So I have 2 parentheses 4y plus 7 minus 6y equals 12. And then I distribute and solve. So I have 8y, 2 times 7 is 14, minus 6y equals 12. And then I combine like terms and solve. So 8y minus 6y is 2y, plus 14 equals 12. And then I'm going to subtract 14. So I have 2y equals 12 minus 14 is negative 2, where I'm going to divide by 2. So my y value equals negative 2 divided by 2, which is negative 1. And just like before, we're going to take that y value and substitute it back into one of the original equations. So if I substitute it into the original equation, the first one, I have 4 times negative 1 is negative 4 plus 7. Negative 4 plus 7 is positive 3. So x equals positive 3. So my coordinate, or my ordered pair, would be 3, negative 1. Okay, so if we look at the next equation, this one is solved for y on the first equation. So we're going to take y equals 4x, and we're going to substitute 4x in for the y in the second equation. So it becomes x plus 4x equals 5, where all I have to do here is combine like terms and then solve. So x plus 4x is 5x equals 5. Then I'm going to divide by 5, so x equals 1. Again, to find the y value, we're going to substitute that back into one of the x values, whichever equation you find fit. So if I substitute it into the first equation, 4 times 1 is 5, so y equals 5. So my ordered pair for that one is 1, 5. If I look at number 5, the first equation is solved for x. So I take the value of x, which is negative 4y, and I'm going to substitute it in for the x in the second equation. So I have 3 times negative 4y equals plus 2y equals 20. Then I distribute and solve. 3 times negative 4y is negative 12y plus 2y equals 20. And then I combine like terms. Negative 12y plus 2y is negative 10y equals 20. And then I'm going to divide by negative 10. So y equals negative 2. Again, that finds the y value, so I have to take my y value and substitute it back into one of the originals. If I substitute it into that first equation, then it's going to be negative 4 times negative 2, which is positive 8. So x equals positive 8, where my ordered pair will be 8, negative 2. Number 6 is a special one because, yes, they're both in slope-intercept form where I could easily graph it and solve it, but I want to show you how we can apply substitution to this. So the idea is you take one of them, since one of them, well, both of them, but since one of them is y equals 4x minus 1, I'm going to take 4x minus 1 and substitute it in for the y in the other equation. So what you end up doing is you end up writing 4x minus 1 equals the other equation, 2x minus 5. And then you solve like you normally would. I'm going to move the 2x over, so it becomes minus 2x. 4x minus 2x is 2x minus 1 equals negative 5. Then I'm going to solve for x by adding 1. So 2x equals negative 6. I'm going to divide by 2, so x equals negative 3. And then I take negative 3 and I'm going to substitute it back into one of the original equations. If I do the first one, negative 3 times 4 is negative 12. Negative 12 minus 1 is negative 13. So my y value is negative 13. My ordered pair ends up being negative 3, negative 13. If I look at number 7, just some more practice problems. This time it's solved for y, so we're going to substitute 3x plus 8 in for the y and the second equation. So if I rewrite it, I have 5x plus 2 parentheses 3x plus 8 equals 5. Distribute and solve. So I have 5x, 2 times 3x is 6x, 2 times 8 is 16. Equals 5. Combine like terms, so 5x plus 6x is 11x plus 16 equals 5. I'm going to subtract 16, so 11x equals negative 11. Divide by 11, so x equals negative 1, where I'm going to take negative 1 and substitute it back into the original. So 3 times negative 1 is negative 3. Negative 3 plus 8 is 5, so y equals 5. My ordered pair ends up being negative 1, 5. Okay, number 8 is exactly like number 6, where both equations are in slope-intercept form. So then you kind of just get to choose which one goes where, technically. Since y equals to x plus 6 on the first one, I'm going to take x plus 6 and substitute it in for the y in the second equation. So it's written x plus 6 equals negative 2x minus 3, where then I'm going to solve for x by adding 2x to both sides. So x plus 2x is 3x plus 6 equals negative 3. I'm going to subtract 6 to both sides, so 3x equals negative 9. Then divide by 3, so x equals negative 3. I'm going to take negative 3, substitute it back into one of the originals. If I do the first one, negative 3 plus 6 is positive 3, so y equals positive 3, where my ordered pair, my final solution is negative 3, 3. Oops, like that. Number 9. Where one of them is set equal to x, I'm going to substitute negative 3 in for x on that first equation. So I have negative 3 minus 3y equals negative 15, where I'm going to subtract or add 3, I apologize, where I have negative 3y equals negative 12. I'm going to divide by negative 3. So y equals negative 12 divided by negative 3 is positive 4. Where y equals 4, but then I'm going to substitute back 4. Now, the trick about number 9 is since I solve for y equals 4, I have no choice but to substitute 4 in for the first equation because there is no y value on the second equation. So if I were to substitute 4 in for the first equation, negative 3 times 4 is negative 12. Oh, I better write that out. So I have x minus 3 times 4 equals negative 15. Negative 3 times 4 is negative 12 equals negative 15, or then I would add 12. So x equals negative 15 plus 12, which is negative 3. So my actual ordered pair is negative 3, positive 4.